Okay, Year 7, I just wanted to go over the steps that we go through in order to use Pythagoras' theorem to solve for a side on a triangle. Okay, essentially Pythagoras' theorem allows us, if we know two sides of a right-angled triangle, to find the third side of the right-angled triangle. So first of all, you have to identify that you have a right-angled triangle. So I've drawn a right-angled triangle here on the board. Some right-angled triangles that you have, they might look back the front to that or upside down. First thing you need to do is work out where is the right angle, and the side opposite that right angle, or the longest side in the triangle, is called the hypotenuse. The other two shorter sides can be called the legs of the right-angled triangle, or we can just talk about them as the shorter sides. Okay, so when we're solving a problem, the first step is to identify which is the hypotenuse on your right-angled triangle. So for the triangle ABC that I've drawn on the board, the side that's the hypotenuse is AC, and that's the length that we don't know. So I'm told that AB is 5 meters and BC is 8 meters. Your second step is to write out a form of Pythagoras' theorem. A squared plus B squared equals C squared. It doesn't really matter what letters you use, but normally we use A, B, and C. But it has to be the sum of the squares on the shorter sides is equal to the square on the longest side. Okay? Step 3, we now substitute or replace those letters with the values that we know. So I know that one short side is 5 meters and the other short side is 8 meters. Okay? So I replace my A squared plus B squared with 5 squared plus 8 squared and say that that's equal to C squared, or the hypotenuse squared. Okay? Now, step 4 is I can just do some calculations. 5 squared is 25, 8 squared is 64. So the sum of those is 89, and that's what the hypotenuse squared is equal to. So my next step is to say that therefore the hypotenuse is the square root of 89, at which point I grab my calculator, I type square root, so square root of 89, and the calculator gives me an answer. Okay, it's 9.43. And in this case, my original measurements were meters, so these are meters. Okay, anytime you use Pythagoras' theorem, these are going to be the steps that you follow. I'll probably try to video a couple more examples of using Pythagoras' theorem so that you can see how I go through each of those steps to solve the problem.